Welcome student to Praveen Patil College of Diploma, Engineering and Technology, our department Humanity and Science. Subject Applied Mathematics, name of faculty myself, Mrs. Smita Shekhar Kamble. Application of derivative is the chapter number 3. The application of derivative is useful to apply the maximum minimum concept we have to concern in today's lecture in detail also. So last lecture we have to continue from the example we reach up to discuss the maxima and minima of the function tan x minus 2x y is equal to tan x minus 2x. In maximum and minimum value, we have to most find the first order derivative and second order derivative, and we have to put the first order derivative is 0. We derive both the values of x, then we identify the value of maximum and minimum at the point x comma y. It is the main procedure behind this. So we have to take the y is equal to tan x is minus 2x. dy by dx, that means we have to differentiate with respect to x to both sides. We have tan x derivative is sec square of x minus 2. We have to again differentiate with respect to x. We know that f of x raised to n is n f of x raised to n minus 1. Our f of x is what? Sec x. That's why 2 f of x into derivative of f of x. So 2 sec x into tan x. Minus 2 derivative 0. So we have 2 sec square x tan x. We have to consider dy by dx equal to 0. So sec square x minus 2 equal to 0. Sec square x is equal to 2. Sec x is equal to plus 2 and minus 2. From the trigonometric table, the root 2 and minus root 2 gives the value for the angle x is equal to pi by 4 and 3 pi by 4. Pi by 4 is how much? Anybody tell? 45, and 3 pi by 4 we have to consult. So pi by 4 we have to put the value of, instead of x we have to put in d square y pi by 4 tan pi by 4. Sec square of pi by 4 it is root 2 sec pi by 4 root 2 square 2 2's are 4 into 1 4, so 4 greater than 0. That implies the function is minimum at pi by 4. Now we have to put the pi by 4 instead of x in equation number 1. Tan pi by 4 minus 2 pi by 4. So tan pi by 4 1, 2's are pi by 2. So 1 minus pi by 2. The value of y. The function minimum at x is equal to pi by 4 and 1 minus pi by 2 at the minimum condition. Now we have to put x is equal to 3 pi by 4. So instead of x, d square y, x square 2 sec square 3 pi by 4 tan 3 pi by 4. We have the 3 pi by 4 for sec. Sec 3 pi by 4 is obviously root 2. Sec square of pi by 4, that is root 2 bracket square is 2. 2 into 2 into minus 1, because tan 3 pi by 4 it is obviously minus 1. 2 2's are 4 into minus 1 minus 4. Minus 4 less than 0, we prove that the function is maximum at x is equal to 3 pi by 4. Now we have to put the 3 pi by 4 in equation number 1. Tan 3 pi by 4 minus 2 3 pi by 4. Tan 3 pi by 4 is minus 1. 2's are 4, so 3 pi by 2. So minus 1 minus 3 pi by 2. So we have x is equal to 3 pi by 4 and y is equal to minus 1 minus 3 pi by 2 is the maximum condition at the point. In this example, we knew the trigonometric ratios, trigonometric angle, derivative of trigonometric function, which is acceptable, compulsory. Our example, which are theoretical part, are start. The rate of working of an engine is given by the expression 10V plus 4000V, where V is the speed of engine. Find the speed at which the rate of working is the least. S is equal to 10V plus 4000V. With respect to V, we have to take the derivative. Derivative of x1, derivative of v1. Derivative of 1 upon x is minus 1 upon x square. That's why derivative of 1 upon v is minus 1 upon v square. v square into 10, obviously 10v, and we have to simplify 4000. So we have to derive this as a d square v. How it is possible? No. We have to take the second order derivative. Derivative with respect to v, derivative of constant 0, 1 upon v square. Derivative of 1 upon v square, again minus 1 upon v square, minus minus become plus, and 2 remain there, 8000 upon v cube. Now, what we have to consider? ds upon dv is equal to 0. We have the dy by dx is equal to 0. In this example, we have to consider with the v. V is the, what we have to consider, the v is there, what? V is the speed of engine. Let us understand. Now, we have to consider ds upon dv 0. 10 minus 4000 v square is 0. V square, this goes this side, so 10 v square, so we have to divide 10 this side and v square this side, so it is 400. V is equal to plus minus 20. So v is equal to 20, we have to put the 8000 upon v cube, 20 cube. So obviously it is greater than 0, so s is minimum at v is equal to 20. So we have to prove that at least means minimum, so v is equal to 20 is the speed of that engine. A metal wire of 40 cm long is bent to form a rectangle. Find its dimension when its area is maximum. We have 2x plus 2y is equal to 40. Why? Because the metal wire is the bent. So that's why 2x plus 2y is equal to 40, because the area of rectangle is A plus B is equal to total area. But A is what? 2 times length and 2 times width. So x plus y is equal to 20, y is equal to 20 minus x. Area x into y. So we have to define capital A, x in bracket 20 minus x. So 20 into x, 20x minus x into x is minus x square. Derivative with respect to x, derivative 1, x square derivative minus 2x. Order second derivative, d square a upon dx square is minus 2. We have to put dA upon dx is equal to 0. That means 20 minus 2x equal to 0. So x is equal to 10. Put x equal to 10, d square a upon dx square is minus 2. So we prove that area is maximum at x equal to 10. So we have to put x is equal to 10 in above equation. So we have the 10, 20 minus 10. So obviously y is 10. So x equal to 10, y is equal to 10, which is the very interesting and useful example. A beam is supported to the end uniformly loaded. The bending moment M at the distance x from the end given by M is equal to VL upon 2 into x minus W, that is W, I pronounce it, upon 2 into x square. Find the point at which M is maximum. For maximum it is much less than 0. So we have to consider M is equal to WL upon 2 into x minus W upon 2 into x square. So differentiate with respect to x because x variable is available. So dm upon dx, so derivative of x is 1, derivative of 2x is x square is 2. X 2 get cancelled, wx and wl upon 2 remain as the same. Again take the derivative with respect to x, d square m upon dx square. What is the derivative of x? 1. So w is remaining. What is the derivative of constant? Is 0. So dm upon dx is equal to 0. Now our first derivative is wl upon 2 minus wx is equal to 0. wl upon 2, 2 multiply this side, or we have to shift minus wx this side. So ww get cancelled. So we derive x is equal to l upon 2. Put x equal to l upon 2 in second order derivative, which is obviously minus w is derived. So less than 0, the point x is equal to l upon 2, m is maximum. We have to prove. Very interesting example. A rate of working we have to consider, discuss above. A bullet is fired into mud bank, penetrate 120 t minus 3x00 t square m in t second. After impact, calculate maximum depth of penetration. S is equal to 120 t minus 3600 t square. What is variable here? Yes, that is t. So we have to differentiate with respect to t. ds upon dt, derivative of t is 1, derivative of t square is 2t. 120, 2 into 36, 72. So 120 minus 7, 200 t. So differentiate with respect to a t again. d square s upon dt square is 120 derivative is 0, minus 720 t derivative is 1. So minus 720, it is obviously less than 0. We have to define the value. So ds upon dt 0. So 120 minus 72200 t is equal to 0. 120 is equal to 72200 is t. Therefore t is equal to 1 upon 60. So we have the already minus 720 less than 0, that is maximum depth, but we have to put the value of t 120 upon 160 t instead of t, and 360 into 1 upon 60 square. So simplify, we have to derive the 60 square is 3600 t, bracket get cancel, 6 into 2 to it is minus 1. So 1 meter we have to derive. Be careful about this example. 36 metal wire we have to consider. Fewest example is 40. So rectangle rectangle length is x, breadth is y. 2x plus 2y is equal to 36 is the perimeter. Yes, understand. So take 2 common obviously. So we have y is equal to 18 minus x. So area x into y. A is equal to x. We have to consider first area is x into 18 minus x is the another side. So 18x minus x square. Derivative with respect to x, x derivative 1, x square derivative minus 2x. Second order derivative, 18 derivative is 0, minus 2x derivative is minus 2. We have d square a d upon dx square is minus 2. We have to put d upon dx is equal to 0. That means 18 minus 2x is equal to 0. So minus 2x is equal to minus 18. 2 divided by minus 18x equal to 9. We have d square a upon dx square is equal to minus 2 less than 0. That means its area is maximum at x equal to 9. And we have to put the x is equal to 9. In this equation we have 18 minus x, that is 18 minus 9. So y is equal to 9. So we derive length is 9, breadth is 9. That is called the dimension of the area with the maximum condition is proved of the metal wire in the form of rectangle. Cartesian form of the radius of curvature. It is the formula rho is equal to 1 plus dy by dx whole bracket square 3 by 2 d square y upon dx square. Exacting the point m1, and we have to consider this portion is the radius of curvature. We have to define in a mathematical way. We have to take the example. A telegraph wire hangs in the form of the curve y is equal to 2 sin x minus sin 2x. Find the radius of curvature of the wire at the point x equal to pi by 2. We have y is equal to 2 sin x minus sin 2x. Taking derivative with respect to x, 2 cos x minus 2 cos 2x. Second order derivative d square y upon dx square. Cos x derivative minus sin x. Cos 2x derivative is minus sin 2x into derivative of 2x is what? 2. That's why minus minus become plus, minus 2 sin x plus 4 sin 2x. Now we have to put x equal to pi by 2 already given. So instead of x we have to put dy by dx is equal to pi by 2. So 2 cos pi by 2 minus 2 cos 2 get cancelled. Pi by 2 it is not, it is cancelled this way because this is angle, be considerable. Pi by 2 is 90. Obviously cos 90. And here we have to derive, we have to cancel these 2, so cos pi. So we have to derive final answer is 2. D square y upon dx square minus 2 sin pi by 2 plus sin 2 pi by 2. So my answer is minus 2. We have to put the value of radius of curvature is 1 plus dy by dx bracket square 3 by 2 d square y upon dx square. Value of dy by dx is 2. Value of d square y upon dx square is minus 2. So it is the final answer of the radius of curvature. If you simplify, you derive the 2 square is 5 raised to 3 by 2 upon minus 2. Find the radius of curvature. Y is equal to x cube at 2, 8. Y is equal to x cube. Taking derivative with respect to x, 3x square. D square y upon dx square, 6x. 0.2, 8. So dy by dx we have to put x is equal to 2, 12. D square y by dx square, x is equal to 12. We have to put the value in equation. Rho is equal to 1 plus dy by dx bracket square 3 by 2 d square y upon dx square. We have to put 12 square 3 by 2. So 12 square is 144 plus 1, 145. And we derive upon 12. So simplify and we derive by calculator rho is equal to 145.50.